Okay, Pre-Cal, here is your super exciting review video with some select problems. So here we go. If the sine of theta is equal to root 5 over 10 and tangent is less than 0, meaning that you know it is negative. Okay? So where is the sine positive and the tangent negative? That must be in quadrant 2. So we will draw the diagram and then find the remaining trig functions. So remember, we're drawing a right triangle that has an altitude either dropped or raised to the x-axis, never to the y. So here's our variable right there. This is our angle. Sine is opposite over hypotenuse, so opposite over hypotenuse. So we're after this adjacent side, and this adjacent side will be negative. So use Pythagorean theorem. So 10 squared equals root 5 squared plus b squared. So that's 100 equals 5 plus b squared. That is 95. Therefore, b is root 95. So negative root 95. So let's go from there and let's find the remaining trig functions. Be careful on the signs. So the sine was given. So if the sine is root 5 over 10, let's go ahead for the cosecant. Its reciprocal, which would be 10 over root 5. And go ahead and rationalize that because you love Jesus. So that's 10 root 5 over 5, which reduces to 2 root 5. So that's our cosecant, 2 root 5. Okay, next, cosine. And remember, we're in quadrant 2. Cosine should be negative. So adjacent over hypotenuse, negative root 95 over 10. And go for that secant. The secant will be 10 over negative root 95. And let's go ahead and multiply. I really don't need a negative there. Don't worry about that because the whole thing is definitely staying negative. So that's going to be 10 root 95 over negative 95. And then we can simplify that by taking out the 5's. So that is, let's see, 2 root 95 over negative 19. So there's our sine, there's our cosecant, cosine, secant. All right, here we go. Tangent, the tangent. And we're right off this diagram. Tangent, opposite over adjacent. So that is opposite over adjacent. Once again, it needs to stay negative. Rationalize that. And that is going to be, something's going to come out of there. So think about this as instead of 5 times 95, because that's an irrelevant number, this is 5 times 5 times 19 all over that negative 95. So the 5 is coming out, the 19 is staying under. So the tangent here is going to be 5 root 5 times 19, or excuse me, just times 19. And there we go. And then, of course, we need to simplify that again. So I'm going to keep moving down even though I'm running out of paper. That's going to be root 19 over negative 19. So that's your tangent. Then your cotangent. And yes, I know this has had crazy radicals in it, but I believe in you. The negative 95, root 95 over 5. This one's actually easier because of the properties of radicals. Remember back from the good old days of Algebra 1, we can put that all underneath one radical, and we will have, and really we could have done that over here, and we will just simply get negative square root 19. So here's all our answers. Remember, we were given the sign. You have to draw the diagram on the test. There's your cosecant, your cosine, your secant, your tangent, and your cotangent. Once again, in quadrant 2, the sign is positive. That means the cosecant is positive. But cosine, secant, tangent, and cotangent, all negative. Everything's hinging on you getting this diagram correct. If negative 3 root 6, 4 is a point on the terminal side of angle theta, find the trig functions in simplest radical form. So let's draw this point on the coordinate plane. So again, I've got us in quadrant 2. So we'll put it 3, let's see, root 6 is 2.5, so 3 times 2.5, we're talking back about 7.5 up 4. So it's a point that is approximately right there. So when we draw this in terms of a right triangle with our theta right there, so that's back 3 root 6 up 4. Let's go ahead and let's find our hypotenuse this time, is the unknown. Thinking that the x value is negative, the y value is positive. So using Pythagorean theorem, 4 squared plus 3 root 6 squared, doesn't matter if it's positive or negative, equals c squared. So 16 plus 3 root 6 squared is 3 squared is 9, root 6 squared is 6, that is 54. So 16 plus 54 is 70, equals c squared, square root, square root. So our hypotenuse is root 70. Root 70 will not simplify. 70's factors, if you want to think about them, 2 times 35, 5 times 7. No perfect square factors in there, so nothing's coming out. So let's go for it. So the sine of theta is going to be opposite over hypotenuse. Every single one of these are going to need to be rationalized. I'm going to go ahead and do that to kind of save time here. The sine is positive. The cosecant will also be positive. That's going to be hypotenuse over opposite. So root 70 over 4. I will come back here because we can simplify this fraction. 2 root 70 over 35. There we go. Okay, so sine, cosecant, both positive. Now let's go for the cosine. The cosine should be negative, and it will be negative 3 root 6 over root 70. And let's do what I should have done on that last problem. Let's go ahead and simplify underneath this radical first. 6 over 70 is going to be 3 over 35. So anything to make those numbers smaller, always a good plan, ladies and gentlemen. And that also means that we won't have to simplify a radical later. So our cosine here is going to be negative 3 and 35 on the bottom, of course. And then 3 times 35 is root 105. Once again, there's nothing to come out. Notice that the cosine is negative. All right, let's get a clean sheet of paper because I'm probably running out of room in order for us to get that secant value. So secant is the reciprocal of the cosine. So we're after secant here. So secant is going to be root 70 over 3 root 6. And of course it will be negative. So let's do that same simplification again. So this will be root 35 over 3 root 3. All we did was take a 2 out of both of those numbers and then cancel them. So let's rationalize our denominator. So negative root 105 over 3 root 3 times root 3. So that becomes 9. So here is our cosine, here is our secant. And let's finish it off by finding the tangent and the cotangent. We're going right off the diagram. The tangent of theta, tangent opposite over adjacent, 4 over negative 3 root 6. Rationalize that denominator. 3 times 6 is negative 18. Simplify the fraction. That is 2 root 6 over negative 9. And thankfully, the cotangent is going to be the easiest one as it is adjacent over opposite. So negative 3 root 6 over 4. So here are all of them. One more time. The sine. Where'd it go? The sine right there. 2 root 70 over 35. The cosecant, the reciprocal, root 70 over 4. The cosine, negative 3 root 105 over 35. The secant, negative root 105 over 9. The tangent, negative 2 root 6 over 9, and the cotangent, negative 3 root 6 over 4. So once again, sine and cosecant are positive. Cosine, secant, tangent, cotangent, all negative because we're in quadrant 2. Let's draw a tangent graph. I felt like we had lots of practice with sine and cosine in class, so we're going to quickly draw this tangent graph. The biggest thing to remember regarding the tangent graph is that the period of the tangent function is only pi. So we're going to take pi and divide it by our b value, which is 1. So our period is staying pi units long. Now, we do have an a value of negative 1/2, which means we're going to be making the turn on our tangent branches at the 1/2 mark. Now, we do have x minus pi over 4 inside the parentheses. Remember, always set bx minus c equal to 0 in order to find the phase shift. So when we solve for x, we see that the phase shift is to the right, pi over 4. So I'm going to go ahead and put pi over 4 right there. And that, of course, is where my branch is going to cross that midline, or in this case, the x-axis. There is no d value, so there's no need to raise that midline up or down. Okay, now, if our period is pi, that means that we need to go pi over 2 to the left and put in an asymptote, and then pi over 2 to the right. So 1/4, 2/4, 1/4, 2/4. So this is pi over 2. This is 3 pi over 4. And we are going to have a second asymptote right there. The entire graph has shifted pi over 4 units to the right. Now, our a value is negative, so instead of an increasing branch, all of our branches will be decreasing. So now let's put in some points here. So there's the middle, and then halfway back, we shall go up. Halfway over, we shall go down. And here is one branch of our tangent graph. We could easily draw another one just by counting off how many fourths? 1, 2, 3 fourths, 4 more fourths. So 1/4, 2/4, 3/4, 4/4. So this would be 4/4, 5/4, 6/4, and 7/4. Here we go. So again, halfway in the middle, halfway up, and here is a very quick second branch. The period is pi, a is negative, the branches are decreasing, a phase shift, pi over 4 units to the right. Find the angular speed of a car tire that has a radius of 17 inches and its linear velocity is 68 miles per hour. So when we go after angular speed, that is radians per minute. I'll let it be, okay? I will be very specific on the test what unit of time, but I'm just going to call it radians per minute. So angular speed, angular velocity, that's what we're after. So we're going to start with this 68 miles per 1 hour. We also need to incorporate the given information that the car tire has a radius of 17 inches, which translates to its circumference being 34 pi inches. So we need to go from miles per hour to radians per minute. The key to dimensional analysis is canceling what you do not want. So right away, we do not want hours. We want minutes. So let's dump that hours and change it to 60 minutes. Next, we do not want miles. We want inches. So let's unload those miles. 1 mile is equal to 5,280 feet. Miles are gone. We still want inches. Keep going. 1 foot is equal to 12 inches. Now we've got inches, but now we can relate the inches per minute. We can relate to radians by writing a unit multiplier utilizing the circumference. So the circumference of the tire, which is 34 pi inches, is equal to 2 pi radians. Every time the tire rotates one time, it is revolving 2 pi radians. So now inches have canceled, and the only units that remain are radians and minutes, and that's what we want. That's when you know when you're done. Now, please avoid a careless mistake by simply multiplying everything across the top first and then just letting it chill in your calculator. So 68 times 5,280 times 12 times, and of course over here we can cancel the 2 pi and the 34 pi 1 over 17. That'll just make things easier, so I'll just plug in a 1 right there. That's my numerator. Just let that number just lurk in your calculator for a few minutes, and we're going to grab it when it's time. Okay, now we're ready for the denominator. All that's in the denominator is 60 times 17. So, take a look at the calculator here. The calculator has both calculations stored in it. So, in order for us to just utilize the calculator here, we just need to go back up and grab the top number and divide it by, and then grab the next number and enter. There we go. So this car tire is rotating 4,224 radians every minute. 4,224 radians every minute. That is the car's angular speed. Remember, angular velocity or angular speed is the angular displacement of the particular object, in this case a car tire. So that is a quick review, a video review for what's on our test tomorrow. And please go back, utilize all the things that we've talked about in class, and I think you guys are going to be amazing.